Assalamu alaikum. Well, hope you guys are enjoying good health. And our today's lecture is about the properties of gases. And let's start. Here are some of the basic points which we'll discuss in this topic, like introduction to gases, diffusion, its definition and explanation, examples and application, diffusion. Oh my God, Pike. Effusion, its definition, explanation, its examples and applications, and further on pressure, definition and explanation, and how to measure the pressure, discussing different types of instrument, barometer, its definition, working principle and types of barometers. Okay, introduction to gases. What are the gases and its properties? The fundamental properties of gases are they are compressible, they have low density, and they have the ability to expand, as we know, because the molecules are far apart from each other and they are randomly moving wherever they are present in a closed box, in a closed container. That is why they are compressible, because of the huge distance between the molecules, and they have the ability to expand. And we can apply the gases in different technologies, like in the propulsion system, means in the rockets for the upthrust, and in different medical treatments because of their versatility. Now come towards its first property. The first property is about the diffusion. What is diffusion? It's basically a spontaneous mixing of gas molecules because of the random thermal motion, because we know the kinetic energy of the gas molecule are high, due to which they randomly move in a container, and which leads to the uniform distribution. And what is the kinetic theory of gas? As far as this theory is concerned, is the random motion of gas molecules results in the process of diffusion, and which result in the homogeneous spreading of gases from one place to another. And what is the importance of diffusion? We observe the process of diffusion in our daily life in different aspects, like diffusion involved in the distribution of essential gases in the biological systems and also in the atmosphere. And what is the application of diffusion? In our daily life, the first application is the use of the perfume. When we use the perfume, the smell spread in the whole room. That's just because of the process of diffusion. As a molecule comes out, they mix with each other and move from one point of the room to the other. In different industrial process, we use the process of diffusion, like in the gas separation and absorption. And here are some of the examples of diffusion, like gas exchange, perfume spreading, food coloring in water, heat transfer in cooking. Well guys, my video is quite realistic. You can hear every type of sound during my lecture. Anyways, let's move on. Ink spreading on paper and tea brewing. They are all the examples of diffusion. Effusion, its definition and explanation. Here is the definition of effusion. It's the escaping of gas molecules through small opening or pores, and this is due to the random thermal motion of the molecules. And the mechanism of effusion is basically the passage of molecules through a small aperture. Aperture means small hole. And the importance of effusion is it is used in the separation and purification of gases, as well as it is used in different industrial applications, in different industrial processes. In atmospheric science, we can use the process of effusion, and in the efficient gas delivery system, we use the process of effusion. Here is example and application of effusion. The process of effusion is used in helium balloons, hot air balloons basically, in which helium low molecular mass helps the rapid diffusion through a small bores of the balloon, due to which the balloon deflate over time. And the second is spacecraft design and effusion. This process is used in the spacecraft defined for the propulsion purpose, and also used in the minimization of gas leakage, as well as in maintaining the atmospheric condition for the astronauts. Here is the example of effusion. Right now, Right now you people are seeing the small hole in the middle of the box due to which from which the gas molecules move from one point to other, from one place to other. So basically this is the basic difference between the diffusion and effusion. Like in the effusion process, the gas molecule moves through a small opening. And we can also consider another example related to effusion is the when our car's tire get punctured, what happens? Gas comes out from the tire tube through a small hole. It's basically an example of effusion. Now, pressure definition and explanation. What is pressure? It is basically the force which is exerted by a gas per unit area on its surrounding, and describe the intensity of the force applied. And the relationship between the force and pressure is directly proportional to the force. The more force you exert, the more pressure created, but it is inversely proportional to the surface area over which the force is applied. The very basic example to understand this concept of the inverse relationship between the gas and the surface area is the use of pipe while giving water to the plant. Whenever you compress the pipe, the pressure of the water becomes giving water to the plant. Whenever you compress the pipe, the pressure of the water becomes high, which means when surface area becomes low, the pressure becomes greater. So this is the inverse relationship, because one quantity decrease and other will increase. But the relationship between the force and pressure is direct. The more force you exert on the pipe, the more pressure will be created. So in this way, I think you can better understand the relationship between the force and the pressure from the daily life example, in which the use of pipe while watering is the best example. How to measure the pressure? We can use different instruments for measuring the pressure, like manometers for pressure measurement. Manometer use the difference in fluid level to precisely measure gas or liquid pressure. And the other one is barometer for atmospheric pressure. Barometer is used to measure the atmospheric pressure and provide essential data for weather forecasting, aviations, and understanding the climate patterns. So these are the two instruments which we use for measuring the pressure. Well, there are different types of barometers: mercury barometers, aneroid, and digital barometers. In the mercury barometers, highly accurate measurement can be taken, but require careful handling due to mercury toxicity, bulky, and it's not portable equipment. In the aneroid barometer, it's compact, it's portable, and less fragile, means it's not easily broken as compared to mercury barometer, but it's less accurate but more user friendly, means we can use it easily. And the last one is digital barometer, which provide a very accurate and precise readouts, means reading, and it can be integrated. We can join it with any electronic device. It is less susceptible to mechanical wear and tear, means it is solid and less. Here is a diagram of the different instruments for measuring the pressure. This is a mercury barometer. Right now people are seeing a large reservoir in which mercury is present, and the tube, the height of the mercury in the tube show the height of the mercury column, and in this way we use this height for measuring the pressure. Here is the aneroid barometer, and this is the digital barometer in which the digital reading is present for measuring the pressure. Thank you so much. Allah Hafiz.